We're continuing roots and radicals, simplest radical form. So we talked about all these three rules. First one, so we got to make sure if we have square root, we cannot have two copies of anything because the index is 2. If we have cube root, that means we cannot have 3 copies of anything. Similarly, if you have fourth root, then you cannot have 4 copies of anything. If there's 3 copies of anything, you take it out. 4 copies of anything, you take it out. Now the second one says no fraction appears with a radical sign, so which means you cannot have square root of something over something. The third one says no radical appears in the denominator, which means if you have fraction, the top you can have square root or no square root, that's fine. But on the bottom you cannot have a square root, a radical square root or cube root. So this is not allowed. Fraction is not allowed. So now we can look at example, another example. Example 5. -8 square root of 3 divided by square root of 20. So in this case, we can see there is a radical in the denominator, which is not allowed, violating the third rule. So what we're going to do is we want to get rid of this radical in the denominator. Previously, in the example, we had a square root 3 on the bottom, something on the top, square root of 3, and somehow we were able to change 3 to a 9 by multiplying both the top and the bottom by the same number, square root 3, because square root 3 times square root 3, that will give us a square root 9, which is equal to 3. The radical sign will disappear after we simplify that, because 9 is a perfect square which contains 2 copies of 3. Again, if we are allowed to have a radical on the top. But this one, if we do the same thing, multiply by square root 20, it's fine, but we have to reduce the radical later, or number later. But what I like to do first is whenever I see radical numbers, I want to check rule number 1 to make sure the number does not contain 2 copies of anything. For example, 3 under square root, 3 is a single copy. We cannot factor it as 2 copies of anything. But 20, apparently, it has 2 copies of 2 because 20 is 4 times 5. And so I'm going to go ahead and simplify the bottom. Okay, so we're going to keep the top, -8 square root 3. For the bottom, 20, I can write it as 2 times 2 times 5, or you can write it as 4 times 5. And notice either 4 or 2 times 2, that's a perfect square. That should come out the radical sign. That gives us the top, copy it. The bottom, we get a 2 out of the radical sign. And then that leaves us a single 5 with the radical sign. Now, it still violates rule number 3. There's a radical in the denominator on the bottom. So we're going to get rid of this radical 5. By the way, 2 is allowed. 2 is not a radical. It's a whole number. It's allowed to be in the denominator. It's just a radical 5. Square root of 5 is not allowed. We have to get rid of this. Again, in order to get rid of that, you have to have 2 copies. And in order to get 2 copies, we only have 1. So we're going to multiply another copy of square root of 5. By the way, we're not multiplying 5. We're multiplying another copy of square root of 5. So that will give us that 2 will stay. And then square root of 5 times square root of 5 gives us square root of 25. Square root of 25 apparently is just a single 5. On the top, -8 stays on the outside of the radical sign. And the 3 and the 5 both are under the radical sign. We can multiply them to get 15. And we continue to simplify this. Notice the top and the bottom. Again, we have radicals in this, but it's still a fraction. Any fraction should always be reduced. And so this 2 cancels that 8. That gives us a 4 on the top. So we have negative 4 square root of 15 over 5 on the bottom. By the way, 15 and 5 cannot be reduced because although they have a 5 in common, but this 5 is on the is not with the radical sign. 15 is with the radical sign. We cannot reduce numbers not with the radical sign or with the radical sign. So this is the simplest form. And we check one more time that this satisfies all 3 rules. First, under the radical sign, 15 is 3 times 5. No 2 copies of any number. Secondly, under the radical sign, no fraction. It's 15. 15 is not a fraction. And thirdly, in the denominator, it's a whole number 5. It's not a radical number. So it meets all the 3 rules. And so this is the simplest form. Now next, the last example, we're going to look at it. It does not really have any fractions involved, but it's going to be a cube root. We haven't done many examples of cube root, so we're going to look at one more here. So to simplify this, we're going to break down 81. So 81 is 3 times, first of all, we can maybe break down, do the factoring tree here. So 81 is 9 times 9. And 9 is 3 times 3. This 9 is also 3 times 3. So as we can see, 81 is actually 3 times 3 times 3 times 3. And remember, if it's cube root, the index is 3. We need to find 3 copies of number. As we can see, we have 3 copies of 3. They can come out and become a single copy. And copy down the cube root symbol. Don't forget to write down this index 3. And there's a single 3. It has to, because it's not 3 copies, it has to stay with the radical sign. So the answer is 3 cube root of 3. And also this meets the requirements. If the index is 3, you cannot have 3 copies of anything. And apparently 3 is a single copy. And we don't have any fractions, so we don't have to worry about rule number 2 or number 3. All right, so that's the simplest form.